We will move to the next numerical. So this numerical also has been asked in the recent exam in 2023. So there is a circuit given here. The switch is opened at t is equal to 0. Solve for v dv by dt and d square v by dt square at t is equal to 0 plus. It means the switch is opened at t is equal to 0. It means that at t is equal to 0, the switch is open. It means that at t is equal to 0 minus, okay, the switch was closed. At t is equal to 0 minus, the switch was closed. So in this is a circuit given. So you can see here the arrow, indication of the arrow. The switch is open at t is equal to 0. Okay, that means at t is equal to 0 minus, the switch was closed. Okay, so hence the voltage across the capacitor is 0. So if this switch is closed, then what will happen? This 10 amp current which is coming here, so it will take this short circuit. Okay, so no current will go to the other elements of the network. Hence, the voltage across the capacitor is going to be 0. So we indicate it as VC of 0 minus VC of 0 minus is equal to 0. Okay, so VC of 0 minus is also equal to VC of V of 0 minus, that is V of t is the node voltage which is indicated. So the voltage across these 2 points is also equal to the voltage across the capacitor. Next, at t is equal to 0 plus, the network is as shown below. Means that at t is equal to 0, the switch is just open. The switch is open at t is equal to 0. So at t is equal to 0 plus, the switch is just open. So when the switch is just open, so this is the circuit here which is shown. Okay, so there is a resistance. So the current and this, the voltage across the capacitor will not change instantaneously. Hence the voltage across the capacitor will remain to be 0. So when voltage is 0, that means it is a short circuit. So this capacitor is replaced by the short circuit at t is equal to 0 plus. And VC of 0 plus is also 0 because as soon as you close this switch, the capacitor will not get charged. Okay, so the voltage which was before, that is at t is equal to 0 minus, the same voltage will be there at t is equal to 0 plus. Hence VC of 0 plus is equal to 0. Now at t is greater than 0. After the switch is open, okay, the circuit is connected to capacitor and the resistor. So it will take some time. Now the capacitor will actually act as a capacitor. So we can replace, now we can represent it by 1 microfarad capacitor which was given in the question itself. Okay, so now the circuit will be this. This will be the circuit. So there is a resistor, there is a capacitance, and there is a current source of 10 amps. So writing this KCL equation for this KCL equation at this particular node. Okay, so incoming current is 10. Okay, 10 is the incoming current at this direction. Incoming current to the node, and by default we will assume the other branch currents to be outgoing. Okay, so this is outgoing and this is also outgoing. So incoming current is 10, which is equal to outgoing current, which is V divided by 1000 kilo, sorry, 1K. Okay, and capacitor current is how much? 10 raised to 6, 1 microfarad, okay, into dV by d. So at t is equal to 0 plus, we will substitute the condition at t is equal to 0 plus, the t is replaced by 0 plus. Okay, so the t is replaced by 0 plus. Okay, so here there is a v of t. Here also there is a v of t. So in this, t is replaced by 0 plus. When you replace it by the 0 plus, so this we have rewritten the equation here. Now we will calculate what is the value of dv of 0 plus by dt from this equation. By substituting v of 0 plus is 0 here, so this whole term will become 0. Okay, this whole term will become 0. So remaining is what? Dv of 0 plus by dt will be equal to 10 divided by 10 raised to minus 6. Okay, so if I calculate this, so it will be equal to 10 into 10 raised to 6, which is 10 raised to 7 volt per second, which is the value of d of v of 0 plus by dt. Now we need to, since in the question they have mentioned d square v by dt square also we need to calculate, we will differentiate this equation 1, okay, with respect to t. So when I differentiate with respect to t, the equation 1, I get here dv by dt, okay, into 1 by 1000, and here it is 10 raised to minus 6 d square v by dt square from this term. So I get this after differentiation. Again, we will substitute t is equal to 0 plus. It is t is replaced by 0 plus, and we will substitute the value of this. So this we have calculated as 10 raised to 7. Okay, and the only variable in this is d square v by d square v of 0 plus by dt square. And now we will substitute and we will simplify. So we get minus 10 into 10 raised to 9 volt per second square.